Do you see the PDF now?
Yes, doctor.
Okay. So we were talking about how to calculate the angle between TAB and TAC. So I will add a question here. And the question is, calculate the angle between TAB and TAC. Okay, look, if they ask you find the angle between TAB and TAC, or they ask you find the angle between AB and AC, it is the same. Okay, so it's equivalent to asking. So if they ask calculate the angle between AB and AC, of course you will get the same result. Okay, this is why we have several methods to calculate this angle. We can take, so I will write them here. So this is angle beta I am interested in. I want to find this angle beta. Okay, I can write it in this way. I can say the angle beta is between vectors TAB and TAC. Or I can say the angle beta is the angle between also vectors AB and AC. Okay, and also I can say it's the angle between what and what? Between unit vector of AB and unit vector of AC. So all I'm saying is true. So I can do it in 3 ways. This is why the easiest way, since you have already calculated unit vector of AB and unit vector of AC, okay, you can directly use them. Okay, so first method, I can say that simply cosine of beta is equal to unit vector of AB dot unit vector of AC. Okay, and in this case I don't have to divide by the magnitude because it's 1. So this is why it's easier to play with unit vectors. Okay, so it's equal, if you want, to if I do the dot product unit vector of AB, okay, so I should divide by the magnitude. But what is the magnitude of unit vector of AB? It's 1. And what is the magnitude of unit vector of AC? It's also 1. This is why, since it's 1, we can say that cosine beta is simply unit vector of AB dot unit vector of AC. Okay. So now, if I want to apply the dot product, how I do it? So I should do the component of UAB along x times, okay, times the component of UAC along x plus the component of UAB along y, okay, times the component of UAC along y, and finally plus the component of UAB along z times the component of UAC along, along y, times UAC along z. It's fine. Okay, how to apply it numerically? This is the unit vector of AB, okay? To simplify, I will call this number, the magnitude here of AB, I will call it A, okay? So this is a certain number calculated, okay? And unit vector of AC here, I will call it B. So now, what is the x component of UAB, of the unit vector of AB? It's minus 16 over A, okay? So if I want to apply it, it's equal to minus 16 over A times, what is the component of unit vector of AC? Who will tell me? Look, this is the expression of unit vector of AC. So along I, it's minus 16 over what? Over B. Okay? So here it's times minus 16 over B plus. Now I will multiply the Y component. What is the Y component of unit vector AB? Yalla, who will tell me? Look at the expression here. What is the component of UAB along Y?
8 over A.
Very good. I look at the J component, it's 8, and I divide by A. So it's plus 8 over A times, now if I look for the other vector, for unit vector of AC, also along J it's 8, but I divide by magnitude of AC, which is B. So it's times 8 over B. And finally, for Z components, it is minus 16, so plus minus 16 over A, and times for AC, it's also minus 16, so times minus 16 over B. Okay, and try to do the formula. If you do the formula on TAB, TAC, you will get the same result. Why? Because look, if you do TAB.TAC, you should do TAB.TAC, but you should divide at the end by magnitude of TAB and magnitude of TAC. So you will get exactly the same result as we did here. Okay? Any question?
Yes, doctor, I have a question.
Yes.
Can we go back to the slide where they wrote about example 6?
Yes, of course. The first slide, you mean, of example 6?
Yes.
Okay. Yes.
Didn't they write here that TBC is 1200 lbs, not TAC?
It's a typing mistake. Okay. It's a typing mistake.
Okay.
It's AC. Okay.
Okay, thank you.
You're welcome. So please fix this. This is cable AC, not BC, because we don't have a cable BC. It's cable AC.
Yes, Dr. Bas, would it be helpful if we find the resultant, if we find it graphically here, and they said only find the resultant, unless they ask if we want to.
If you look, when you have 3D, I don't advise you to use geometrical methods. It's very complicated, and it's not enough to just draw it, because when they say find the resultant, it means you should find it as a vector. You should know its magnitude. You should know its direction. Okay.
Mm-hmm. Yeah.
So yes, you can draw it, but it's not enough, because if you just draw it, I will ask you what is its magnitude, what is its direction. And since using geometry in 3D is very complex, so I go to the analytical way.
Okay, perfect.
Okay, guys, so we are done with this chapter. Any other question before we close the session? Okay, thank you. So,
Doctor, the next time we're going to start the second chapter immediately.
Yes, but look, we'll have a lot of practice together. And I just want to do the next chapter for you to see the whole picture, and then we will start doing problems on all chapters. And I will do review problems on everything we have already done. Okay?
Yes, thank you. Thank you.
Bye.